Hey, welcome back. In this Earth Science lesson, we will be discussing natural resources and then we'll talk a bit about conservation. We've already done metals and minerals and fossil fuels, so today we will try to focus just on air, water, and some of the other resources we get from the land besides the minerals, metals, and fossil fuels, which we have discussed. And we will talk a bit about human impact on those natural resources as well. Now, this could turn into an hour-long discussion on all the ways in which humans impact the environment. I don't want to make this video about that. I've done it before with other videos on my channel. We'll try our best just to focus on the resources themselves. So, natural resources as part one. Now, water is the most important resource on the planet. We can't do anything without water. Now, I guess technically you would die sooner without air, but water is, it's life. We can't grow food, we can't sustain life, we can't manufacture, we can't do anything without water. Now, water, as important of a resource as it is, it's not necessarily a ready-to-go resource. First of all, most water on the planet is unusable salt water by our standards, but around 5 million people a year die from water-borne illnesses, pathogens, and things like that. Now, in the developed world, such as if you're watching this video, most likely where you live, we don't even think about water. You turn on the tap and it comes out, but those systems can be compromised. Flint, Michigan, I don't know if they have water still, and it's been about 6 years since that disaster where they got lead in their system. In other places, they run out of water because they pump it from underground. We'll discuss that shortly. Groundwater, well, actually, we'll talk about it right now. Water is a renewable resource, except not all the time it isn't. Now, Earth will never run out of water, in general, in total, but the vast majority of this water is not usable by us. Only 3% of Earth's water is freshwater, and 2/3 of that is frozen. And that's not water that makes any economic sense or practical sense to use. So only really 1% of the fresh water is usable for us. And almost all of it is underground. Now, in the not too distant past, before the Industrial Revolution, we couldn't use any of that water. So we couldn't grow nearly as much food, and population numbers stayed under 1 billion. Whereas today they've absolutely exploded, and access to water and the ability to grow food is kind of one of the number one reasons for that, along with fertilizers that allow us to expand how much food we can grow as well. You think of lakes, all the surface water, that is a tiny, tiny, tiny portion of the water that's available. So we very heavily depend on groundwater. Looking at this map of the United States, we'll pick California because they use the most water, not just because I live there, but look at the water withdrawals from underground. 28,800 million gallons a day. That's just about 29 billion gallons of water every single day that is drawn up just in the state of California. I don't know what 29 billion gallons of water looks like. I don't know in terms of size how big it would be. I could figure it out. I haven't done it ahead of time, but you should figure that out just to see what is the quantity of water that is. It's amazing. In the country, this is 10 years ago, so who knows what these numbers are like today. For withdrawals of water, now this is total. This is surface water and groundwater. Thermoelectric power, the cooling of, to make electricity, we have to get things hot and we have to cool those things down. And water is how we do that. Virtually all of the water used for that is surface water that can just be replenished. It's really not being polluted or anything, but 160,000 million, so 160 billion gallons of water every single day is used just in the United States to do that. The public supply is 42 billion gallons of water. So let's do some math really quick. 42 billion divided by population of the United States is about 325 million. That is 129 gallons of water per person every day, every single day. It's unbelievable. Now that goes into like public supply is not just private in my home. In my home, I do not use 129 gallons of water a day, but there are other services that I use that require water. So there's many things factored into that. And irrigation for crops. Again, 115 billion gallons of water every single day. Now, what's sort of nice about this is if we look at, here's the red line is population of the United States, but for the last 40 years, we really have not increased our water usage. In fact, it's basically gone down overall. So we've gotten more efficient with what we're able to do with our resources, which is a key. We don't want to have to say we have to cut back necessarily, because that can lead to lower quality of life, and that's not our goal either. Groundwater around the world, again, it's a non-renewable resource. The majority of these underground sources, these aquifers, the water is being taken out faster than it is being replaced. So we cannot continue to irrigate in these places forever. At some point, they will just simply run out of water. And then what the heck do we do? Even in places that are in the blue, such as the Ogallala Aquifer, it's not that simple, because it's only certain regions where the water recharges faster than it is discharged. For example, in Clovis, New Mexico, there are parts of that town that are just out of water. You turn on your sink, your shower, and nothing happens. So people have to bathe their children with bottled water that is sent to them by relief efforts. Not good. Even when human activity is not really responsible, we can run out of water. So this is around the area of Redding, California. And the drought is sort of gone, but around the year 2014, it was so bad that there's just so little water in the state. And we're powerless to really do anything about that right now. Maybe in the future, some sort of technology will fix it. But right now, we don't really have anything. Now, when it comes to compromising our water, there's two kinds of pollution that we discuss, I guess. Point source pollution simply means we know where the pollution came from. We can pinpoint it. Non-point source pollution is way more common. It's really hard to know where a certain pollutant comes from. You go to the water and you can tell there's trace amounts of like engine oil or gasoline that got spilled or something like that. Well, that could have came from anybody, anywhere, at any time. Because there's runoff. When it rains, that water washes a very large area into a smaller area, such as a lake or a stream. It's very hard to know exactly where the pollution is coming from. And when it comes to plastic pollution, this is perhaps, apart from what's happening to the atmosphere, our greatest offense. Although we are also causing species to go extinct at catastrophic rates. 8 million tons of plastic end up in the oceans every year. And the warming of this isn't really pollution, but the warming of the oceans caused by the warming of the atmosphere, which is caused by excessive carbon dioxide emissions by humans, that is killing coral reefs at a rate that is so fast that we basically have to conclude that it has to be entirely due to human activity, because we're just seeing unprecedented changes. The really depressing thing about plastic in the oceans is we almost can't do anything about the plastic that's in the oceans, because UV light from the sun breaks the plastic down into microparticles, and there's no net or anything that can clean those up. So plastic in the ocean seems like it's a problem that we have to fix right now. We should have fixed years ago. Now, what's nice is in the United States, we have the third largest population, but our contribution to plastic that ends up in the oceans is way down the list. Now, really, it needs to be zero for there to be any sustainable health for the oceans, and I don't know how we get to zero, but this is a very good sign. We look at China and Indonesia and the Philippines, these have huge populations, and they are serious offenders when it comes to plastic in the oceans, but there's no reason that they cannot be as little, how do I want to say this? There's no reason they can't have as little of an impact. There we go, I found the words. There's no reason they can't have close to as little of an impact as we do. China's will always be larger because their population is larger, but this number can come significantly down, and it really needs to. Here's a picture of a bleached coral reef. So the coral reefs dying is, to the oceans, it's the equivalent of our rainforests disappearing, which they are too. We'll get to that later. First, we'll talk about the atmosphere for a bit. Now, human activity, or the chemical composition of the atmosphere, a lot of it is balanced by life. A very long time ago, hundreds of millions of years ago, there was vastly more carbon in the atmosphere than there is today. And there was more oxygen in the atmosphere as well. But these things happen on incredibly slow scales. Human activity has rapidly changed the atmospheric composition. Really, it's only in terms of methane and carbon dioxide, but it's been an extreme change. Pre-industrial revolution, we were looking at about 240 parts per million CO2. Today we're over 400 parts per million. Now, here's the number. In 2017, 45 billion tons of carbon dioxide. Just an unbelievably large amount of carbon dioxide. Before humans, there was carbon dioxide in the atmosphere. There were trees and grasses and oceans and photosynthetic organisms in the oceans. They were busy absorbing carbon dioxide. This 45 billion tons of carbon dioxide we release into the atmosphere, some of it is absorbed. Close to half of it is absorbed. But the rest is not. It can't be. Which means of all our extra carbon emissions, half of it is added to the atmosphere, and that just simply keeps increasing year after year. And that's why the concentration of carbon dioxide is higher in the atmosphere than it was 150 years ago. And it's why the planet is warming. It's really not very controversial. And the carbon dioxide also forms carbonic acid and makes the oceans more acidic. Big reason why coral reefs are dying as well. Now, what you need to understand, because some people don't understand this and then they try to use it as a gotcha. Carbon dioxide, it's not a pollutant. It's not directly harmful to your health, but it is a greenhouse gas, and the fact that it's warming the planet is detrimental to human well-being, and you could argue human health as well. Now, when it comes to pollution, the worst offenders have been identified. They were identified decades ago. And luckily, we've made a lot of good progress on this. We've decreased our pollution significantly. There's also, when you get gas, it says unleaded. And I always thought that was a really weird thing to put on. Like, why would gasoline have lead in it? And why would you label it? That's like if you bought candy bars, they said, does not contain broken glass. Well, it shouldn't contain broken glass. But actually, throughout almost all of the 20th century, gasoline had lead in it. And so every car and airplane and boat was spewing lead out of their tailpipes into the environment. And it caused huge amounts of problems. It caused irreversible brain damage. It increased violent crime dramatically. Terrible, terrible consequences for that. Now, there has been legislation that has passed. We'll discuss this towards the end here, which has dramatically dropped our amount of pollution that we make through these sources, which is quite the accomplishment because we use more energy. We burn more fossil fuels, but our pollution has actually gone down. So it's a very, very, very good thing. And then also there's been the fact that we get our energy in different ways. Natural gas is far superior to coal for burning to make electricity. Natural gas in its purest form really only creates carbon dioxide and water. Those are not pollutants, and we don't want all that carbon dioxide, but we can live with that for now. Coal makes lots of nasty pollutants when you burn it, and even the hole in the ozone layer has been shrinking. So transportation is the number one source for air pollution. It's not the factories, as a matter of fact. But again, here's the figures for 1970. Cars are more fuel efficient, factories are more efficient. So the amount of all of these pollutants, carbon monoxide and all these others, is far less than it was back then. Very, very good. And here's a visualization of the hole in the ozone layer, and it's getting smaller. Here's the lead. So in the 70s, just look at how much lead there was. And then it began to drop precipitously. I don't know when officially it was banned. I think officially it was made national law in the 90s, and now we can see there's virtually no lead detectable. Well, not no lead, but there's extremely tiny amounts of lead detectable out in the environment. I guess, but I don't know exactly what method they used to collect this. But while this was all going on, before we were able to ban lead, people in government just lied, or they made up their own facts on the spot, which isn't the same thing as lying. Or they hired people to manipulate, to use words in a manipulative way, or just lie. They would say that, yeah, there's this amount of measurable lead in the environment, but that's because that's just what we would naturally find in the environment. If we banned leaded gasoline, we would see absolutely no change. Well, that obviously wasn't even close to true. So we have to know these things. It's important. Now, when it comes to land, fossil fuels and minerals dominate. And when it comes to these resources, our concern is not that we're going to run out of them. Our concern is, what is extracting and using them doing to our planet? So all of the negative things about fossil fuels. We'll try to just focus on things maybe you've never heard before. So, for example, surface mining causes a huge amount of erosion. The human activity, this obviously is erosion, but even after the mine sort of shuts down, it can lead to a lot of erosion as well. The process of extracting these, in this case it's coal, the process of extracting it also pollutes the environment significantly. Here's a river that I don't know what exactly causes it to be this color, but there are problems with polluting the environment while we are extracting these resources. Not just the practice of burning them, as they are used as fuel. But there are some silver linings. Renewable and greener energies are becoming more common, and the problems that do exist are drastically less common than they used to be. Oil spills happen, but they do not happen on the scale like they used to even only 10 years ago. There's a significant, well, maybe not 10, but 20 years ago, there's a significant improvement. Now, forests. Deforestation is complicated. Globally, in the last maybe 2 decades, the amount of trees on the planet has actually increased. But that still isn't a good thing, and here's why. The primary reason why the number of trees around the globe has increased is not because we stopped cutting down trees. It's because huge areas of Canada and Russia, which have always been too cold for trees, are now warm enough for trees to expand into. And those are the 2 largest countries on the planet. That's really not good because it's a symptom of our warming planet. And it matters where we are losing trees, because half of the rainforests have been cut down in about the last 120 years. Now, in 100 years, will the rainforests be completely gone? Well, I don't know. I really hope not. Around 50% of our pharmaceuticals come from the rainforest. So it's not just because, the pretty flowers and the pretty animals and all of that. Our livelihood, to a significant extent, depends on these things. Now, the reason that rainforests are cut down is not for the wood. In fact, one of the most common methods, perhaps it's the most common way in which forests are cleared, is they're burned, so you can't even use that wood because you've burned it. So agriculture is the number one reason, sorry, my nose itches, number one reason for deforestation. Nothing to do with logging. So for example, this is palm oil, or it's a palm oil plantation. Row after row of these specific types of palm trees that can only grow in tropical climates, which means we have to burn down the native, incredibly ecologically diverse rainforest to create a monoculture of the exact same plant where really hardly any animals can make a living. And it's terrible for ecosystems, and it's causing huge extinctions. We really won't be going over extinctions today, but I encourage you to look up some of the data on just the rate at which species are going extinct right now. It's very alarming. Here's an example of that, where rainforest has been taken away. Now, there are ways where we can use the environment, because we have to use the environment in order to live, but we can do it in a responsible way. So here in the top left, this checkered pattern, it kind of looks fake or like a glitch, but it's not. Those are just places where trees have been taken out. Now, that's what we call clear cutting. Selective cutting is what we see over on this end. So we do patches of trees where we take them out. This allows animals to be able to move through this environment and migrate. For many animals, it seems kind of silly, but this square of green here that is surrounded by clear-cut forest, those animals are basically on an island. They can't necessarily escape from there. So this is more environmentally friendly. And when it comes to agriculture, we'll do a few videos upcoming about agriculture, but as of 2015, already close to 40% of all the land on our planet is farmland. That is really amazing, considering, again, in Russia and Canada, those countries are so enormous. China as well is the third largest country by area. Those countries are so large, but the vast majority of land area in those countries, you really can't do any kind of agriculture there. And then we have to consider all the deserts, such as the Sahara Desert, the entire continent of Antarctica, plus many others. Around a third of all land on this planet is desert as well. And then we have, I don't remember if I said mountains, but mountains. So we already are using almost all of the available land for agriculture. The only way to realistically be able to do more agriculture is to move into the rainforests, which I just don't think that would be a responsible thing to do. Another problem with agriculture is we rely very heavily on irrigation from groundwater, but that deposits salt on your topsoil, and at a certain point, the soil is completely sterilized for hundreds, if not thousands of years. That is a recipe for total collapse in an immediate area. Those people, by the millions, would have to either leave or starve. And what if other countries and regions won't accept them? So, big problem. Potential big problem. The solution to this, to me, seems to be why don't we figure out a way? I mean, we've landed on the moon. Why can't we take ocean water and turn it into like pure fresh water? We know how to do it. We just don't really do it on a big scale. Some countries do, like Israel has a massive desalination infrastructure. it's a desert and it's next to the Dead Sea. So they make pure fresh water to be used for agriculture. Theoretically, perhaps a couple hundred years in the future, we make so much fresh water that we turn the Sahara Desert into a green, lush area, kind of like the Midwest of the United States. And then we don't need the rainforest anymore. That would be a very good thing. Okay, so on conservation, just a few things. Conservation is just the, I'd rather say intelligent use of resources. If you, let's say you win the lottery, you win $1 billion, well, you spend $1 million every day, you run out of money in 3 years. That's just an unintelligent way of using your resources. And when it comes to groundwater and the forests and things like that, we are, in a lot of places around the world, we are using them in a way where we know there's no future long-term in it. So that's conservation. Now, these two pieces of legislation in the United States were the most important ones historically for protecting the environment. Richard Nixon created the EPA, and then these two pieces of legislation have cleaned up our air and water in really dramatic ways. And we actually already saw the effects of that. Just sort of a brief explanation. This won't be 100% perfectly accurate, but the way the Clean Air Act works is, let's say Ford is approached by the EPA, the government, or whatever, and they say, okay, Ford, your average vehicle gets 21 miles per gallon. Your goal next year is your average vehicle, or we'll say like 5 years. In 5 years, your average vehicle needs to get 23 miles per gallon, or you will be fined. So that incentivizes the company to be more fuel efficient. They also tell them that their cars have to produce less pollution. Now they do it incrementally, step by step, year by year. But over decades, well, we've already seen the effects of that. It's been a very good thing. So this was sort of the, unfortunately, humans don't tend to mobilize around a movement until a tragedy happens. So this is the Cuyahoga River in Ohio. What do you do when your river is on fire, right? So there were all kinds of manufacturing plants all along this river, and they just dumped all of their waste into the river, and there was no legislation or anything that could stop them. But the river was so polluted that it caught fire and burned for like 2 weeks. And then people kind of grew up. There are several other things that went on. I think using Agent Orange in Vietnam kind of got people to think, maybe there are things we just should not do to the environment and to each other also. There was a book called Silent Spring that was extremely influential as well. But the combination of all these things got people to finally accept the idea of we can't just do whatever we want. Unfortunately, we have amnesia, and where we're at right now is we're sort of trying to go back to a time where there were no rules, and I hope that that is a temporary problem. Pretty much we've already discussed these things, so we've been able to decrease our pollution despite the fact that we've increased our consumption. Very, very good news. So, as I said, we could discuss this forever, but that's where we're going to end this one today. Thank you.